to get them up to an 80, have to give at least 7 here, 9 here. So the better you do, the more advantage you get on points. I'd probably give about 5 to 7 points in this particular case to bump everyone up accordingly. And that's how it would work. Okay, so that's one half. The other half is a little more complicated. It's the same basic procedure, except the categories are not as easy as subtracting 1 every time. You have to actually calculate every single category. So let's look at categories. In categories, we typically have a 5-category scale. Now, if you're going to be a teacher, you're going to teach at the college level, junior college level, even high school, then you could be using this as a potential system. But many of you will use categories because you're going into a field that doesn't give grades per se, they give categories. And a standard category for most professions is a 5-scale category, going with excellent, good, average, fair, and poor. Now there are all kinds of different scales that can be used. I actually like scales that have a superior at the top 10% and a lower 10%. I like that a little bit better because I think it distinguishes better. But it just depends on the situation. But the standard is excellent, and excellent equals 81 to 100%. 81 to 100% would be the excellent category. The good category will equate to a 61 to 80%. Average is 41 to 60%. Fair is 21 to 40%. And poor is 0 to 20. So that's typically how it works out on a 5-category scale. So now what equates to 81%? That's what we have to determine. Because we know that 1.5 standard deviations equates to an A, we need a standard deviation for this as well. So we go and we look in our chart and we find out on the 81 percentile, if we look for the 81st percentile, what is the number that corresponds to it? And it should be, if you double check, it should be a 0.88. So 0.88 standard deviations and above will be considered an excellent category. You want to double check for me, but I think that's it. It's 0.88, right? All right, a good is I believe, because now we're talking about the 61st to the 80th. The good should be, I think it's a 0.28, is that right? 0.28 to 0.87S. Does that make sense? 0.28 to 0.87. Once you set these one time, they're good. They're not going to change. Those categories are never going to change. Standard deviation will change, the mean will change, but the percentiles and the standard deviations here will not change. So average is 41. I believe it's a negative 0.23. Is that right? Yes. Negative 0.23 to a 0.27. That's considered the average. That's the 41st percentile to the 60th percentile. We go down to fair, it's the 21st, and the 21st is a negative 0.81, negative 0.81, up to a negative 0.24. Sometimes people mistakenly put 0.22, but it's not 0.22 because that would cross over because we're going away now from the mean. All right, and then anything at negative 0.82 and below would equate to the poor category. So 5 categories, here's how you do it. It's the same process we use over here, the same exact process. The only difference is that here we will have to calculate each category because they don't have equal units. You can see it goes from 0.88 to 0.28, so that's 0.6. To -23, it's not equal. You got to calculate every single one. So we do the exact same thing though. We know that our mean was 69, our standard deviation is 12. So all we have to do is take 0.88, multiply it by what? the standard deviation, 12. So with your calculator, take 0.88 times 12, our standard deviation for this data set, and then add 69. 79.56. And if we're going to keep it in whole numbers, which we will, 79.56 you said?
Mm-hmm.
So we'll round it to what? 80. Now keep in mind, this is going to differ from your homework, because in your homework when we get the categories, it's a new data set. So you will have to run the new data set. I'm just using the same mean and standard deviation so we can see the process, but you can go in, run the mean and the standard deviation for the new data set, and it is done in tenths, I believe. So you will have to do the scale in tenths. You always do the scale according to whatever the data is formatted. So if it is coming in tenths, then you do your scale to tenths. If it's in whole numbers, like this one was, then you do whole numbers. All right. So that being said, you said it was a point what? 79.56, but since we're in whole numbers, we're going to round it to 80. So 80 and above will be considered the excellent category. 80 and above. But make sure you determine how many do you have, and I'll look at Excel at the end because I have it on the computer, and we can figure out how many we have. So anyone that had an 80 or above is going to be considered in the excellent category. Now we have to go to the good category. And good is a 0.28. So 0.28 on your calculator, take 0.28 times the standard deviation of 12 plus 69. That equals what?
72.
72. So 72 to 79, that's going to be the good. Anyone that scored a 72 to a 79 would be considered in the good group or good category. All right, now we go to the next one. Average is negative 0.23. Multiply that times 12, add 69, the mean, and that gives me 66, okay? So this is 66 up to a 71. All right, then I go down to my next one, a negative 0.81, same thing, times the standard deviation of 12 plus the mean of 69. 59 to 65. And then the last one is simply 58 and below. We don't have to do any math on the last one. And then we can see how many fit in each of these categories. Okay, so we went back, we looked at our Excel, we did a sort of the raw scores, and we found out that scores that equated to 80 or above were how many? 3. 72 to 79, how many? 6. 66 to 71?
3.
59 to 65?
4.
And 58 and below? 4. Okay, so we can look at our groups, and if we were doing these groups based on some kind of workout regimen, we may say that, okay, these are, well, they wouldn't be vertical jump scores. They could be in centimeters maybe, but they wouldn't be that. But if they were some score, say it was throwing velocities, and we were doing an arm routine that day on strengthening the throwing arm, we could take the excellent group and take those 3 people, send them off to one field. And they're doing a specific training program for them. We'd have 6 in the good group, 3 in the average group, 4 in the fair group, and 4 in the poor group. And we could train all those groups differently if we wanted to single them out in some criteria, like this particular test. So that would work out. All right, so that's how it would actually be done. That's the process of doing it. Let's go ahead and do the next one. I'm going to get the mean and standard deviation on Excel.